Hello everyone. In today's video we will be going over this little packet. It goes over some more types of transformations, and I'm going to get more specific here. We talk about reflections, and vertical stretches and compressions. So on this first page, we're just going to look at a before and after of these sets of graphs. Just notice what is changing about them. Before I do that, let's do a tad bit of review. F of x equals x squared is the quadratic function. F of x equals x cubed is the cubic function. And this one is exactly as you'd read it. It is the square root function. Now we look at these graphs on the top and bottom and see how we change from before to after. And this is done by multiplying the function by a -1. So now you'll see a negative in front of all of those. Hopefully you see the difference, especially in the first and third sets. What we're doing is we're taking our graph and we're flipping it over the x-axis. So now it looks upside down. On the cubic specifically, we take the arrow that's pointing up to the right, and now we have it pointing down on the right side. And then on the left side, instead of pointing down, it points up. So at the bottom, it says describe what is happening. The graph is, now we don't say flipped, this is called reflected. It's a reflection. But you can still put flipped in parentheses over the x-axis. And in this class, we'll only be looking at reflections over the x-axis, not anywhere else. On the next page, we're going to practice graphing some of these. There are 5 in total, 1 for each type of function that we've been talking about in this unit. First, we have f of x equals -x squared plus 3. First, we want to think about the parent graph, which is f of x equals x squared. And remember that this graph has a U shape to it. First thing we want to do is find the transformations. So we're going to look at the original function and compare it to ours and see what the changes are. There are 2 changes. First, we have a negative in front. That means reflection. Again, we do that over the x-axis. Since we're reflecting it, that means our U shape is actually going to be upside down. So this is the way our graph should look when it's done. Second thing is this plus 3. And I want to make a distinction here. Notice this 3 isn't grouped with the x specifically. So if it looked like this is when you would have to look at it as -3 and you would say this is left 3. However, we don't have that. We have this. Since it's not specifically grouped with the x, that means that it's going to be an up or down transformation, in this case up. Now we have to graph it. The first point you find when you're graphing is your vertex. So let's go back up at our equation. Now we don't have any sets of parentheses here to group x. So that means our h value, we can't see it, it's 0. But in case you don't understand that, I will demonstrate. Let's expand this a bit. If I were to write it like this with the parentheses, the only number I can add to it is 0 because that doesn't change it. Plus 3. So it's 0, 3. I'll graph that. And then to make the U shape, I need a point to the left and a point to the right. Because right now, this is the top of the U. But I need 2 more points to help form that shape. So I'm going to use -1 and 1. Now to get their values, their y values, and plug it into this equation. And actually, let's do it from up here. -x squared plus 3. And I'm actually glad I went ahead and did parentheses here because this is going to be important. So if x equals -1, we have negative, in parentheses, -1 squared plus 3. You have to put that -1 in the parentheses. If you don't, that's going to change everything about your problem. So we have to do the exponent first. -1 squared is -1 times -1, which is +1. So now we can look at this as a -1 because I can drop the parentheses. So this is like -1 plus 3, which is 2. And again, for +1, negative in parentheses 1 squared plus 3. 1 squared is 1, so -1 plus 3, which again is 2. And now we graph. -1, 2. I've already got 0, 3, 1, 2. And now we can draw in our U. And that's it. Next graph, transformations. Before I do that, let's look at the equation. F of x equals -x minus 2 cubed plus 1. Parent graph is just the cubed. Yeah, I don't know why I started write y equals as well. X cubed. Remember, that's our disco, right? So it looks like this. Points up and to the right. Transformations, there are going to be 3. We look from the original to what we have. We've got 3 main differences. First is that negative out in front. Again, that means reflection over the x-axis. Second, we have the x minus 2. X minus 2, that means we're going to look at this as actually a positive 2. Meaning we're going to move right 2. And then lastly, you've got the plus 1 on the outside. And that means up 1. Now let's graph it. First thing we need is our vertex. That comes from our h and k up here. Again, you change the h to positive 2, and k stays 1. So 2, 1. Now I need a point to the left and right. So we need 1 and 3. All right, let's plug those in and see what we get. Our equation is negative x minus 2 cubed plus 1. And before I get any further, I forgot to mention this. Since we're reflecting our graph, that's going to change the shape. So this arrow pointing up is going to point down. And then this arrow pointing down is now going to point up. So this is what it should look like when it's all said and done. That's really important to pay attention to, especially on the cubics. Cubics are tricky. All right, back to what I was doing. We're going to plug in 1 to our equation. Negative, in parentheses, 1 minus 2 cubed plus 1. Negative, 1 minus 2 is negative 1 cubed plus 1. Negative 1 cubed, that's negative 1 times negative 1 times negative 1. I'll write it out even. Reminder, we multiply this 3 times. I'm going to get 1 still. And I've got 3 negatives, meaning my end answer is also going to be negative. If I have an even number of negatives, it's positive. If I have an odd number, it's negative. So what comes out of this, negative 1 cubed, is a negative 1. Now I still have this negative in front here. That's going to change this to a positive 1 plus 1, which gives me 2. Now let's repeat that for x equals 3. Here we have negative 3 minus 2 cubed plus 1. Negative 3 minus 2 is 1 cubed plus 1. Negative 1, sorry, let me backtrack here. 1 cubed is just 1. And so we have a negative in front of it. So we have negative 1 plus 1, which gives us 0. And now we graph those two new points. 1, 2. We already have 2, 1, and 3, 0. It's really important on this graph that you think about the shape before you draw it, because a lot of students will look at this and think, oh, it's just a straight line. No, it's not. This middle point here is the middle of the cubic shape. So when I connect the middle point to the point on the right, it's going to go down. And then when I connect the middle one to the point on the left, it's going to curve up. Kind of like that. That wasn't my best. And there you have it. Next graph, graph number 3. F of x equals negative square root of x plus 1 plus 2. First, we have to find the parent graph. F of x equals the square root of x. Remember, this graph has a side stroke appearance. So we start at a point, and then it will move off to the right. Another good tip, this kind of looks like a really not well-drawn square root sign. It has the same shape, how it's kind of starts over here and then just goes up and over. It does the same thing, so that kind of helps. All right, let's talk about transformations. There are 3 from the original to the graph we have now. First, we have a negative there, meaning it is a reflection. Again, x-axis. Since it is a reflection, this is going to be upside down when we flip it over. So instead of going up to the right, it's going to go under and to the right. And I'll just draw that out here. So it's going to look something like that. Something to keep in mind. X plus 1. Since it's with the x, we do the opposite. So this looks like right 1, but it's actually left 1. So again, that looks like a negative to us. And then the plus 2 means up 2. All right, now we make our t-chart. Now with this one, I'm definitely going to need some more space than what I have. So I'm going to extend it with a sticky note. First, I need to find my vertex, which I've already kind of done. Inside number, change it to a negative, the opposite. So this is negative 1. That keeps it positive 2. Now this time, this vertex is the starting point of my graph. And then every point after that has to come to the right side of it. So I'm going to put this at the top of my t-chart. Negative 1, 2. Next, for this equation, the easiest thing to do is to get perfect squares under this square root. So what I want for this next number, because this will give you the square root of 0, I can demonstrate. So I put that negative 1 in there. Negative 1 plus 1 is 0. Square root of 0 is 0, plus 2 is 2. So I got the square root of 0 here. So the next square root I want is the square root of 1. So this is my goal, because I know 1 is a perfect square. So I'm going to intentionally choose a number here that's going to give me that number. So the next number to get 1 under here has to be 0. So x is 0. 0 plus 1 will give me the square root of 1. Square root of 1 is 1, but there's a negative in front, so it's going to be a negative 1 plus 2. And that's 1. Lastly, the next result I want, so I'm going to have a number plus 1 plus 2. Remember, this is just the equation. I'll write that above here. So I'm trying to plug in numbers for x to give me specific numbers. So the next perfect square that I want is a square root 4, because the square root of 4 is 2. It's a nice number. So what number plus 1 gives me 4? 3. So x is going to be 3. So then negative square root of 4 is 2. So I have negative 2 plus 2, which is 0. And there you have it. Now let's graph these 3 points. Negative 1, 2. 0, 1, and 3, 0. And then as you can see, here's my starting point, and then it's going to go off and to the right. All right, 2 more graphs. These are 2 different functions, so we're going to review their names. This one here is the absolute value function. And before I forget, I'm going to do this one. This one is the exponential function. So before we start graphing, we need to identify the parent graph. So we have f of x equals, if we take away the transformations, the absolute value of x. And this has a V shape. Remember, V for value. Now let's talk about transformations. There are 2. That negative out in front means reflection. And again, that has to do with the x-axis. Flip it over the x-axis. And then we have x plus 3. This is where we think of it as the opposite. We think of it as actually a negative 3. So this is going to be left 3. All right, now I'm able to make my graph. And before I forget, since this is a reflection, this V is going to be pointing downward. Something to think about. First point I need is my vertex. So I look. Inside I've got that negative 3. And then outside I don't have anything. So what would be in the K spot is actually just a 0. So we have negative 3, 0. Now I need a point to the left and a point to the right. So I'm going to use negative 4 and negative 2. Using my equation, negative absolute value of x plus 3, I'm going to get these y values. I have x equals negative 4. So I have negative absolute value of negative 4 plus 3. Don't forget about the absolute values here. Keep them until you have thought through them. Negative 4 plus 3 is negative 1, still inside of that absolute value. Now, the absolute value of negative 1 is positive 1. Bring down that negative. That changes my answer to a negative 1. Now let's repeat that for negative 2. Negative absolute value of negative 2 plus 3. Negative absolute value, negative 2 plus 3 is positive 1. Absolute value of 1 is just 1. So again, we end up with negative 1 as our final answer. Let's graph. -4, -1. -2, -1. And again, you can see that V taking shape. And there you have it. One more graph on this page. Exponential function. Remember, these are very special and they're handled differently from the other two graphs I just showed you. So this parent graph specifically is y equals 2 to the x. The transformations I've added, 2 is not one of them. 2 is part of the equation. There are 2 transformations here. The negative in front, again, is a reflection. And I'm going to get to this in a moment. I want to bring back this real quick. The exponential function looks like this. We'll do it over here. As it goes down, it starts to get flatter. And then we've got this absolute asymptote under it that's going to flatten it out. And then as it goes up, it's going to get pretty steep pretty quickly. Now when we reflect it, so this on the right is going to be what my graph has to look like since it has a reflection. We don't reflect it over the x-axis, which is a good thing. It would be far more difficult if we did that than what we're doing with it actually. This asymptote works like the x-axis. So the way the flipping, it looks the same, it's just going to change where it's at on the graph. So it's going to flip over its own asymptote. So when we do that, this is still flattening out and pointing to the left. But now instead of going up, which it can't do because it can't cross that asymptote, it's going to go down. So this is how my graph should look. So I'm going to put here asymptote over asymptote. Our other transformation is this +2. And that's up 2. I want to remind you of 2 things because a lot of students get confused. 1, we will not give you exponentials that move left or right. They're a bit messy. But 2, how I know that this is not left or right, if it's left or right, it would look like this. It would be with the x specifically. So when I mean with the x, I mean with the x. This is not with the x, it's away from the x. So that is all. Now to graph it, it works a bit differently from the other graphs. First thing you want to do is graph the asymptote. Now the asymptote is this number right here. So not only is that how you move up or down on the graph, but it's also the asymptote itself. So the asymptote is y equals 2. So you go to the y-axis for this. So you go to the y-axis and you find 2. It's right here. And you draw your dashed line through it. Just like so. Now usually if it's pointing upward, you go up 1 to meet the starting point of our stuff. But this case, we're going to go down 1 to do that. So starting point is going to be down 1. So since we're at 2, we go down 1, it's at 1. So our point is at 0, 1 on the y-axis. We need 2 more points. Negatives are a bit messy for the exponential function, so let's do the positives. So we're going to go 2 to the right. So we already have 0, 1. Now let's do 1 and 2. Plug those in and get our answer. All right, all we have to do is plug them back into our equation. negative 2 to the x plus 2. So we have negative 2 to the first plus 2. And again, this negative should be considered separately. So you want to do the exponent first. That's not complicated on this one at least. 2 to the first is 2. So it's negative 2 plus 2, which is 0. Now the negative is important on this one. So make sure you put this in parentheses. Negative 2 squared plus 2. We want to square it without the negative involved. So 2 squared is 4, so we get negative 4 plus 2, which is negative 2. There are my other 2 points. So we have 1, 0, and 2, negative 2. That's enough for us to make a graph. So I'm going to graph the right side first as it goes down and very quickly, steeply moving downward. And then over here, it's going to get close to the asymptote and then flatten out. And there you have it. Next page. These are another kind of discovery. Look and see what happened, what changed, along with one example. I'm going to do this 2 times. I've got 2 of these to go through, and then we'll be done with the video. What happens when you multiply the parent function by a number greater than 1? So notice in this first equation, I have just the x squared, which is the parent graph. Then I have it times 5, and then times 10. Visually speaking, as we go from left to right, notice that the graph looks like it's getting narrower. The graph is getting more narrow. Now, of course, that's not what we call it. We have to have a different word for it. This is called a vertical stretch. And one way to remember this, if you look at these as arms, it looks like someone is raising their arms up to the sky further and further as they go. So it genuinely looks like someone's stretching their arms out. Let's look at an example. F of x equals 2 times x minus 3 squared. The original function is just f of x equals, so if we took away the transformations, x squared, which has a U shape. We have 2 transformations here. First we have that 2 out in front. This means a vertical stretch of 2. And our second transformation, we have x minus 3. This is, do the opposite, right 3. Now we get our t-chart so we can make a graph. And we need our vertex, first and foremost. So opposite of negative 3 makes a positive 3. And then k is empty, meaning it is 0. So it's 3, 0. Then we go, so let me graph that real quick. 3, 0. I need to go 1 to the left, so I need to figure out 2, and also 4. To get my y's, I just plug it back into my equation up here. 2 times x minus 3 squared. So for x equals 2, we have 2 times 2 minus 3 squared. 2 times 2 minus 3 is negative 1 squared. Negative 1 squared is a positive 1, so it's 2. And then for x equals 4, we have 2 times 4 minus 3 squared. 4 minus 3 is 1 squared. 1 squared is just 1. So 2 times 1 gives us 2. And now we graph. We only need to go up 2 on the y-axis. You can go further if you want. That gives us 2, 2, and 4, 2. Last but not least, graph the U-shape. And we are done. These other two problems I'm not going to go over in the video, but I will post in the completed notes what these are supposed to look like. So it's a way for you to practice. Back page, we're going to do one more type of transformation, one more example, and then we are done. What happens when you multiply the parent function by a number greater than 0 and less than 1? Meaning between 0 and 1. So here we have again the original x squared, and then when we put a fraction in front of it that's smaller than 1, notice the exact opposite thing happens. Instead of narrowing and getting closer to this y-axis, it's getting further apart from it as we go. So a lot of us look at that and think, oh, it's getting wider. The graph is getting wider. This is called a vertical compression. Now the hint for this, it looks like someone is taking the arms of the parabola and pressing them down back towards the x-axis. So press down is kind of the thing I think of. One more example. F of x equals 1/2 times the absolute value of x minus 3. Our parent graph is f of x equals absolute value of x, which has a V shape. Transformations, there are two. First, we have that 1/2 out in front. That means it is a vertical compression. Of 1/2. The other one is x minus 3. This means we move right 3. All right, now we need to get some points. First, we need the vertex. Inside the x minus 3, we read this as a plus 3. And then we don't have a k, so again, that's like plus 0. So it's 3, 0. Go ahead and graph that. So it's going to look very similar to the graph we did just a moment ago. 3, 0 when you do 1 to the left and 1 to the right. So we're also going to find 2 and 4. Now all we have to do is plug these into our equation. So we have f of x equals 1/2, absolute value x minus 3. Now we're going to plug those in. When x equals 2, we have a 1/2 times the absolute value of 2 minus 3. 2 minus 3 is negative 1. Absolute value of negative 1 is 1. So we have 1/2 times 1, which is just 1/2. And now we do it for 4. 1/2. Absolute value 4 minus 3. 1/2. 4 minus 3 is 1. So it's clear to see this is going to be 1/2 times 1, which is 1/2. So they're both going to go up to 1/2. On the graph, I'm just going to go up 1, and then when I graph these, I'm going to go up just halfway. So 2.5 and 4.5. Now remember, this one's absolute value, so when you're graphing this v, make sure it's straight. It doesn't curve at all, like the parabola, like the quadratic does. Something like that. As you can see, it looks pretty wide compared to the original. What do you think about it? Okay, these two, again, are going to be for practice. I am going to post the completed ones once I'm done with that. So you'll be able to see if you're understanding it. I'd like you to try them on your own first, get a good idea, and then you can look at mine. I hope that this video was helpful. I'm sorry that it is a bit longer. I did cover this material over 2 days, so we did not get through all of this in one period. So that's why it's just an extra long video. If you have any additional questions over this material, feel free to email me or talk to me when you see me in class. Otherwise, I hope you have a wonderful day. Bye!